All right, so this is the notes for logarithms. So this is the start of the second half of chapter 7. So essential question, how do you find the inverse of an exponential function? And I just gave you a little example, so look, if you're looking at example 4a, and that would help guide your steps. Okay, so the main idea is logarithms, so make sure you write that in the left-hand column. Okay, so if we look at this, if we were to try to figure out what x is for each of these equations, we would know here x would have to equal 2, because for this 2 to a power to equal 4, that is 2 to the second power. So that means x equals 2 here. Okay? So here, 2 to what power gives you 8? Third power. So 2 to the third power equals 8. Well, if you plug in 2 to the fourth power, 2 to the fourth power is 16. So 10 is somewhere in between there. So it's somewhere between 3 and 4 for this x value. So take a minute and try and figure out what that is. So do some trial and error. So 3.1, 3.2, 3.3, etc. to see how close you can come to get 10. So go ahead and pause and then figure that out. Okay, so if I were to go to my calculator and just test some things out. So 2, oops, in there. Right. So 2 to the 3.2, almost. 2 to the 3.3, not quite. 2 to the 3.4 power. Whoops, 2 to the 3.4 power. It's about there. It actually ends up being 2 to the 3.33, I believe it is. Yeah, so it's even closer. But we have to do that with trial and error. You don't want to have to do that every time you're solving a problem like this. It just takes too long. Okay? So then we have a system for finding this. Okay? And that's called a logarithm. So here's what the definition of a logarithm says. If I have log base b, that's how you say this, log base b of y is equal to x. Well, this arrow means I can go back and forth between log form and exponential form. So if I were to take this log form and change it into exponential form, this base b here would be the base of your exponential. This x here, which is what this log equals, is your exponent, and then what's inside the log is your number that's by itself. Okay? So for instance, if I had log base 2 of 8 equals 3. Okay, so I have this. So I have log base 2 of 8 equals 3. If I were to change that into exponential form, this base here, b, is my base. The x, which is the exponent on it. And what's inside the log is what it's equal to. Okay? So that's how you can go back and forth. So if I give you, let's say I gave you an exponential. I told you 3 to the second power equals 9. Okay? So I can take this, change it from exponential form to log form. So then this would be log, the base is 3. Now these, since they're together here, they will not be together in this equation. So the 9 actually is inside, and the 2 is the exponent by itself. So we just went backwards. Okay, so we're going to practice that. So this definition, if you understand this log definition, how to change from exponential to log form and log form to exponential, then this whole part of chapter 7 will be pretty easy for you. Okay? All right, so we're going to take each of these and write them in exponential form. So right now they're in log form because you see the word log, and then we're going to change it into exponential form. So let's do part A and B together, and then I'll have you try C and D. So part A, we have log base 2 of 8 equals 3. Okay? So we're going to change this to exponential form. So according to this, the base B is 2. These two have to break up. They can't stay together. So then 3 is the exponent, and that's equal to 8, which makes sense because 2 to the third power does equal 8. Okay? All right, part B. Log base 4 of 1, that's how you say that, equals 0. Well, if we change it to exponential form, which of these numbers is my base? The 4. Because even when I say it, log base 4 of 1, so 4 is the base. These two cannot be together, so that means 0 is the exponent, and that's equal to 1. Again, that's true because 4 to the 0 power equals 1 because anything to the 0 power equals 1. Okay, so now pause this and try part C and D and then unpause when you're ready to check. Okay, so for this one, the base is 12. Again, these cannot stay together. So they break up, so this is your exponent, and then equals 12. Again, that makes sense. Okay, here, your base is 1/4 this time. We like to put the fractions in parentheses. These break up, they can't be together, so -1 is your exponent, and it's equal to 4. And again, that's true. 1/4 to -1 power means you switch these around, which does equal 4. Okay, so you'll have some practice on your worksheet of going from log form to exponential form. Okay, so now we want to evaluate the logarithm, which means we can put this in our calculator. That's what evaluate is. Okay, now your calculator has the log base function on it unless you have one of the older calculators. Okay, so you want to check on your graphing calculator, you hit math, and then I usually scroll up because it's toward the end. So scroll up and you should see log base if you have it. If you don't have this, then you have an older version and I'll show you what to do in a minute. Okay, so you choose log base, hit enter, and then it gives you this prompt to fill in the base and what you're trying to find. So then for the first one, I'm doing log base 4 of 64. So log base 4 of 64. And the answer is 3. So log base 4 of 64 equals 3. Now, if you don't have that log base function, here's what you're asking yourself. Okay? So if you don't have the log base function, here's what you're doing. So log base 4 of 64 equals some number x. Well, then change this into exponential form. So that means 4 is the base. These break up, so x is your exponent. And we want that to equal 64. So then you can do a little bit of trial and error, and you'll still find that x has to equal 3. Okay? So try the next two. Try part B and part C and see if you can come up with the answers. Go ahead and pause and then unpause when you're ready to check. Okay, so again, you could type these in your calculator. So I could do math, and then you find the log base, which is toward the end. Log base 5, and then scroll over 0.2. And you get -1. Which makes sense. So for those of you that had to do the work, you would do 5 to some power equals 0.2. Well, 0.2 is another way to say 1/5. And so it makes sense that x has to equal -1. Okay, so here if you're doing this one, so 3 to some power equals 9. So the answer is 2. And if you typed it into your calculator, you would have gotten that answer as well. But those of you that don't have the log base, if you have an older calculator, then it won't have it on there. So then you have to go about it this way. So 5 to some power equals 0.2, and 3 to some power equals 9. And then you can find it out. Okay, so evaluate means you need to find the answer. I have the boxed answers here. Okay, then we have a little bit of vocabulary here. So we have common logarithm, or for short, it's just called common log for short, instead of saying logarithm every time. So if they tell you log of something and they don't give you a base number, it is implied that the base is 10. So if they don't write log base 2 or 3 or 4, etc., if they don't put a number for your base number, it's automatically 10. That's the common log. So it's a logarithm with base 10. And the LOG button, the log button on your calculator, is the base 10. So then this button here, LOG, that's the log button with base 10. Okay, and you'll notice it's kind of helpful because then it's showing you that if you look just above it, if you were to hit the shift button, it gives you 10 to a power. So it's basically telling you that the log has a base of 10. That's your common log. Okay. Then we have something called a natural log, and it is signified by LN on your calculator. And we talked about that button last chapter when we were doing the E, because E is your natural log. So your LN, or E is your natural base. So LN is the natural log. And yes, I know the N should come before the L if you're saying natural log, but this is actually another form. I'm not sure what, it's either Greek or the other, but it's natural log, ln. Okay, so if you were to rewrite it, it would be log base e for natural log. Natural log is log with the base of e. Your ln button is your base e. That's your natural log. Okay, so I'll show you why that's important. So now we're just evaluating using a calculator. So log of 8. So since there's not a base here, the base is 10, but I don't need to go to log base in my calculator. I can just hit the log button 8. So just hit your log button, 8, enter. So if I were rounded 2 decimal places, which is typically what we do, would be 0.90. And then B, natural log of 0.3. So then you just hit your natural log button, 0.3. And we get negative 1.20. Okay, so if it doesn't have a base on it and it's a log, then the base is automatically 10, but you just use your log button. You don't have to do log base. I mean, you could and you would still get the same answer. And then natural log, you could just hit natural log and then 0.3. But that base is actually an E. So you got to remember that natural log has a base of E. Okay, so example 4. We're going to find the inverse of a function. So if you think back to functions, remember if we're finding an inverse, the first thing we have to do is switch the x and y variable. So switch the x and y variables around. Okay, so on part A, if I were doing step 1, I would switch and I would have x equals 4 to the y power. Okay? Then step 2 is to change the form. So if it's in exponential form, you change it to log form. If it's in log form, you change it to exponential form. So I'm just going to write change the form so that you would go to whichever the opposite is. So for step 2 here, I would do, it's in exponential form, so we're going to change it to log form. So you got to think, what would be my base for this? Well, the base of your exponential is 4, so we have log base 4. These are going to break up because they can't be together in both of the equations, so that means x is inside the log, and then your exponent y is by itself. So then your last step is to do whatever you need to do to solve for y. Well, on mine already, y is all by itself. So the inverse, remember we put the little -1, is log base 4 of x. Okay, so when we're finding inverses, if it starts out as an exponential, we switch the x and y variables, and when we change the form, we change it from exponential to log form, and then solve for y. But this one already had y by itself, so we didn't have to do anything else. We just put that little -1 on it to show it's the inverse. Okay, let's try part B. So first step is to switch the x and y's. So then I have x equals natural log of y plus 3. Now I'm going to change this form because it's natural log. So remember, natural log is a log with a base of e. So I'm going to rewrite it. And that's important because then we're going to do step 2 and we're going to change the form. So right now we're in log form. So to change the form, we have to change it to exponential form. So the base is e. Now remember, these break up. So this y plus 3 goes together because it's in the parentheses. So that breaks up. So that means x is your exponent. And then that means it equals this y plus 3 stuff. Okay. So once you have natural log, first change what it looks like, which means it's log base e. Then step 2, we change the form. So this is in log form, so we change it to exponential form. The base is e. These two break up, they can't be together anymore. So x is your exponent, and then the y plus 3 is over there. Now we do have to do step 3 this time. We have to get y by itself. So we're going to subtract 3 over. So we end up with e to the x. Now make sure the -3 doesn't look like it's part of the exponent, because it is not, equals y. So when I write my answer, you put the y -1 exponent, that's your inverse notation, is equal to e to the x minus 3. That's your final answer. Okay. All right. So go ahead and pause this and you try to find the inverse of this. I will give you a hint. Remember, since there is no base number here, what does that automatically mean the base number is? 10. Okay, so go ahead and pause and try it. All right, so our first step is to switch the variables. First step, so we're going to have x equals log. I'm going to go ahead and write base 10 because there was no base there, which means it's 10 to the x plus 5 inside. Okay. Step 2, we need to change the form. So now this is in log form, so we're going to change it to exponential form. So this base here, 10, is your base. These break up. Oops, I'm sorry, that should have been a y. So these break up, so that means x is your exponent, equals y plus 5. Step 3, I need to get y by itself. So -5. So then you get y inverse equals n to the x minus 5, and that minus 5 is not inside the exponent, it's off at the end. It's basically your k value, the end. Okay, good job. So go ahead and do a repetition and then work on your logarithms worksheet.